Okay, so my name is Thomas. I'm a Ruby developer. I work for a tech company, Pebble. And today I would like to talk about web architecture from a point of view as a Ruby developer. Now, this is quite a wide topic, so therefore I will not cover everything that I would like to. But if you find this topic interesting and you want to follow along, I place some resources, also the slides for the talk on the link below. And I will also make these are available once the talk is released in the show notes. So please think about this talk more like a crash course to web architecture, rather than like I will explain everything. So I will go through three major architectural approaches, which is Monolith, Microservices, and Serverless architectural approach. And then we will look also into some hybrid solutions, if I make it in time. I will be talking a lot about AWS, Amazon Web Services. This is not because I'm any fanboy or something, it's just that purely this is the provider that I have the most experience. So therefore I will be explaining a lot of concepts from their perspective, but there are many other providers you can choose into creating these, solving these problems. Now in order to explain these architectural approaches, we will have a look how to do like this from a perspective of example application. The example application will be like an online store in which you have these responsibilities, product listing, basket, orders, payment gateway, and also we will have a look how to do admin and how to do authentication around those responsibilities. Now let's start with Monolith. Now when it comes to Monolith, that may mean lots of things, what we are really talking about. Is it like, like say back-end front-end split, and in between monoliths there is like some JSON API, or is it just like a mighty monolith as proposed by DHH and Basecamp, where like, backend is rendering the front-end and there is just some sprinkles of JavaScript around it. And also like it really depends what kind of technology are you using. Are you using event loop? You will have different problems than if you use Puma or Unicorn. And also if you choose, let's say, functional programming languages like Elixir and Phoenix framework, you will have completely different sets of solutions and problems. But one thing that most monolith technologies have common is they share the common code base. So all those responsibilities are coupled together. And so for example, if you have a Ruby on Rails application, all you need to do is like generate Rails generates scaffold orders, Rails generates scaffold products, do has many associations in between them, and all that communication will be directly executed via code. Same applies for admin. When you need to introduce like admin in front of all these responsibilities, all you need to do is like make sure that the code will execute those responsibilities of the admin. Same applies for authentication. You will just check whether the current user exists, whether he has a session or not, and then if he has, you will check whether he's able to access those responsibilities. So maybe you will introduce some policy object, or you will check some roles, or etc. So everything, all the communication happens directly via code. When it comes to like deploying them to a server, you will pretty much take your entire code base, you will wrap somehow, like bundle it together and just ship it to server, VM, EC2 instance, or let's say Heroku Dyno. But you need to do that as a whole. If you, let's say, find a typo in your code, you need to fix just that one responsibility, that one part of application. Again, you cannot just, somehow ship just that one part. You really need to bundle that entire code base and ship it as a whole. Similar thing applies for, let's say, if you need to introduce like a background worker. So for example, you need to send like an email to your client. The shipment is on its way. And even though you need to just background worker like Sidekick, Rescue, or Delay Job to send that one email, again, you need to configure entire code base really to like be able to do that. Similar applies to the connection with databases. Let's say for product listing, it may make sense to use persistent storage like Postgres database or MySQL database to store the product details, and let's say use S3 to store some thumbnail images of the products, use Redis for some caching of product details, etc. But then, for example, for the responsibility of, let's say, payment gateway, let's say you only want to write some results after the payment to the persistent database. You don't really care about S3 access or Redis database in terms of storage of a cache. So it's kind of goes everything in monolith architecture. Everything kind of bundles around similar, the entire bundle. Similar if you let's say your application normally needs to be on in load balance environment, like on 2 or 3 instances during normal year, during normal days in the year. But suddenly there's a Black Friday sale, people are hitting your website like crazy. You need to scale up. So you will introduce, let's say, 6 or 7 instances. And you will look at the traffic, and what you will discover is not that many people are actually making payments, or not that many people are actually editing in admin. They are, let's say, browsing the products mainly. But again, you needed to scale as a whole. So this kind of brings us to the point of the microservices. With microservices, what we while as in Monolith, we are trying to build application, and the code is pretty much representing all the bound context in the application, all the responsibilities in the application. With microservices, we tend to do smaller applications, microservices that are responsible only for one thing. And these microservices are independently developable, deployable, scalable. They run as an independent process, etc. So what I mean by that, from a perspective of our dummy application, we can introduce multiple micro applications. So, for example, for the order microservice, we will say, okay, this could be just like a little Ruby Sinatra application. So we will just git init new Sinatra project, push it to its own GitHub repository, and when we want to deploy, we will deploy it to own EC2 instance into AWS, and we will connect its own Postgres database. And same for basket, let's say, again, this could be just a little small Sinatra application in its own Git repository, pushed to its own GitHub repo, deployed to its own VM. And in this case, we will say, we don't actually need, let's say, Postgres or MySQL. We can just store the basket in a Redis, so it doesn't have to be stored forever. And let's say for product listing, we will say, this is a little bit more complicated. Let's just do like a Ruby on Rails application, like a Ruby on Rails API. And again, it will be its own Git project, pushed to the GitHub, deployed to its own set of EC2 instances, and it will have its own connections to, let's say, Postgres, to S3, and Redis to some caching. Now, we are not talking about we are somehow sharing the database with the microservices. It's basically, these are physically separated microservices, so physically separated databases. So product listing has its own database, and the order has its own Postgres database. Now, and imagine for the payment gateway, we will say, yeah, we could build our own solution in Ruby, but let's say there's some good open source project written in Python or Java or JavaScript. Let's just git clone that, push to its own VM, connect it to its own database, and we will run it as that. So there are no cross dependencies. You don't have to worry about bundle update in a Rails application and worry about it will suddenly break the orders. Now, when it comes to that scaling issue that we had before, now let's say, again, it's Black Friday, we need to scale the application, and in this case, we will just scale the product listing microservices. We don't need to scale the payment gateway orders if that's not required. Now, DevOps people in the room may point out that my graph before was wrong. It should look like this. So every microservice should have its own load balancer. And technically speaking, you are right. If we are talking about some classic load balancers, like AWS ELB. But there are many solutions to the same problems. And there is like a load balancer solution called ALB, which is application load balancer, which can actually scale different parts of your application. It doesn't really matter how you do this. It's just more about like there are multiple ways how to do this. Anyway, let's move to another part. So we established that every microservice is independent code base. It has its own database. We are not sharing the databases with microservices in most cases. So how do they communicate with each other? So let's say if a user has like product A and product B in his basket, and he wants to like see what are the products in his basket, how would we then like display that information? Like the names of products and images. So what the microservice can do is like it will pull the information via public API from the other microservice. So this could be something like a JSON API or some other HTTP API. Really depends what you prefer. And it will render it as a part of its response. So the basket will render it as a part of its response. Or maybe if this is like a single page application, you will just load what are the IDs of the product and independently will pull the names of the from the other microservice. It really depends. There are many various ways how to do this. Similar way, like if you have like let's say from the basket you want to start like a checkout process. So you want to create an order, and you want to pull what was in the basket, what are the names. Again, you will pull that from different microservices put together, etc. Now, when it comes to authentication and authorization, we are also aiming for authentication and authorization to be its own microservice, and there are many ways how to do this. The one solution that I will talk about is JWT tokens, but like I'm saying, this is not the only way how to do that. So imagine user wants to log in, and start browsing and buying products. So he will just type email password. That request will go to the authentication service. If the dude is not there, we will say, sorry, try to sign up. If he is inside our system, authentication server will say, yes, you are in, and it will generate JWT token, which looks something like this. You have like a header part and also a body part, and inside the body we will set some variables like like user ID, what is the user role, he's a regular user, he's an admin, etc. And then is the third part, which is like base64 of the first two parts plus some encrypted with the secret. So these three parts are then returned to the front end. So basically, authentication service will return that to the front end, and front end will then send this JWT token with every request to the microservices. So all those microservices are aware of that secret, so they can easily read whether he is telling the truth. So imagine like front end when he wants to display the orders, for example, with the request, front end will provide the JWT token. Backend server will read it. Okay, so you are admin. I can just show you all the products. Or if you are a regular user, okay, I will just orders. I will just show you all. If you are a regular user, I will just show you orders that are for that user 1, 2, 3, 4. Now, when you think about this, this is so counterintuitive because now the front end is telling the backend, trust me, I'm an admin. But the reason why you can rely on this information not being changed, if someone would tamper with like the values in that JSON, the third part will match the first two parts, because those first two parts are readable on the front end. So anyway, I will not go into topic of JWT tokens more, because this is topic for 1 hour talk on its own. But I just wanted to show you like there's a way how to do stateless authentication and authorization in microservice vault. Now, the question now is how much code should be inside the microservice? And there are actually two theories to this. One is saying inside the microservice there should be this much code. Literally just do one thing, finish, return results, and that's it. And second theory is like there should be enough so that the microservices are self-governed around that responsibility. And what we mean by that, so we will go in our presentation with this solution. And what we mean by that self-governed, in order to explain what I mean by that, we still didn't talk about how to do admin in microservices. So where is admin in this case? Is it like some microservice on its own, like some microservice that is managing all the microservices? And this way you are introducing like a God microservice into the infrastructure. And it's similar way how in object-oriented programming we are trying to avoid God objects. So objects that know too much, or they are trying to like manipulate other objects. Same applies for like this. In microservices world, this is an anti-pattern. In some cases you maybe want to do that, but in like most cases you don't. What we're really aiming for is like having like that admin responsibility as a part of every microservice. So for example, the admin part for listing products, so let's say adding new products to the system will be part of the product listing microservice. The admin part for, let's say, changing orders or maybe fixing some address details for the shipments will be inside the orders microservice. And again, thanks to, let's say, JWT token, you know that particular user will be able to see the admin interface, or he will be able to access the admin interface, etc. So the best analogy that I heard about like microservices is like they are like cells in your body. Every cell knows how to replicate, how to scale. Every cell knows how to die off or when to die. So descale. There's no super brain like telling every cell what to do. There's like DNA, but when you think about it, DNA is just the code that every cell is reading. So if you do this right, you might end up with something like this. So this is a slide stolen from another talk by Netflix, Managing Chaos. I really recommend watching this talk. All of those circles represents microservice in their infrastructure. And all those little dots bouncing around, they are representation of HTTP traffic between those microservices. Now, when you think about this, why would Netflix go to such an extent with their infrastructure? And they need to support all those million users, streaming, watching movies. And suddenly there is like a Christmas, so they need to scale up 200 more streaming instances, etc. In microservices, they can easily do that. And then when there is suddenly a bug with, let's say, a subtitle microservice, they will just fix that bug, deploy it only to the subtitle microservices, and they don't have to worry about like bringing down the entire system. So let's say your application is, not about scale. Let's say you have only, let's say, 1,000 customers. Maybe it's like some enterprise software that only 1,000 employees are using within one company, but it's reasonably large. So let's say you need to have, let's say, 3 teams in 3 different time zones to support that monolithic code base. So let's say you have team in New York, team in London, team in India, and everyone is contributing to the same code base. So one problem that you may have is problem with the Conway's law. And what the Conway's law is stating is like the means of communication in your organization will shadow itself on the software. So in simple words, if you have 3 teams in 3 different time zones, which are 3 different communication channels, you will end up with 3 versions of the same software within one code base. So what you can actually do with microservices is you can actually organize your teams around the natural boundaries, around the physical boundaries of the application. So we'll just say team 1, you guys taking care of microservice responsible for product listing. Team 2, you guys will do orders, basket, and payment gateway microservices. Team 3, authentication and authorization, for example. And these teams are fully responsible for the entire lifecycle of the microservice. So from delivering the backend frontend to DevOps deployments, QA, also like doing some support around like, what's going wrong. It's not like there is like team 4 somewhere that will do the DevOps part. Every team is responsible for their own stuff. We are not even talking about large teams. We are talking about so-called two-pizza teams. So teams that can be fed by two pizzas. So that's like 5 or 6 people usually. And the general rule is like once your team is grow beyond what you can count with 2 hands, you should probably just split it. So anyway, this is like interesting theory. I'm recommending reading those articles. They will be in those show notes. So this sounds good. We probably solve all the problems. We solve the problem of scale, of organization of teams, of independent deployability. This sounds all good. So why is not everyone doing this? And one thing that pops to my mind is the cost. Because when you think about it, every microservice needs to have a JSON API. Every other microservice needs to know how to consume that JSON API. Then you need to have, let's say, in between some APIs, you need to guarantee that the message will receive the other a microservice. So you need to introduce like QA mechanisms, etc. So the cost of development is definitely can be felt. And there's also a cost of infrastructure, because when you think about it in our scenario, every microservice is running on its own EC2 instance. So you are paying for every EC2 instance, you are paying for every database, every Redis cluster, etc. Then when you think about like then supporting QA, staging, and also every developer's machine, that could get complex. Now, I don't want to paint black and white picture. There are definitely other good solutions for microservices out there, especially thanks to containerization or Docker, for example. What you can do is actually you can run your microservices as a containers, and you can, with let's say products like ECS, you can actually run different containers within one VM. So, for example, in one EC2 instance, you will run a basket and product listing. In another instance, you will run product listing and payment gateway, etc. Or if you are really dealing with that scenario with like you just need one server in a company, you can just buy like a large enough box with a lot of memory that you can run all those containers in. It really depends what you want to achieve. Anyway, and yes, this is still microservices, because like one of the points is like they are running as an isolated process, which definitely Docker provides. So the cost problem kind of brings us to the point of serverless. And first thing that I need to explain, in order to explain serverless, first I need to explain one product from AWS called AWS Lambda. And so imagine you write your code, you will take some libraries that you need for that code, like SDKs, etc. You will bundle that together to a zip file, and then you upload that zip file to AWS Lambda. Now, what you can do is you can invoke this AWS Lambda from, let's say, AWS CLI, or maybe from some AWS Ruby SDK, and you will pass some parameters, let's say a user ID. So Lambda will get invoked, Lambda will start, load the code, do its job. So for example, in our case, we will pull some data from third-party API for that user, we will process the data, save to database, it will return some results, and it will spin down. So it died. And if that process took 200 milliseconds, you will pay for 200 milliseconds, and plus allocated memory. If it took 2 seconds, you will pay for 2 seconds, plus allocated memory. And we are talking about really cheap price of execution. It's like $0.00014 or something like that. I don't know the price from the top of my head. It's just something like that. And then if you don't need to run this AWS Lambda for another year, you are not paying anything. So you can think about the AWS Lambda the same way I would think about S3 buckets in AWS. So all you care about with S3 is like you have a PDF file or some file, you want to store it somewhere, and then you want to retrieve that file. You don't care how AWS is organizing their servers on their side, you just care that you are able to pull your documents and pay only for what you need. Same with AWS Lambda. You don't care how AWS is organizing their servers. You just care about, here's my code, I want to execute it, and I just want to pay for what I executed. So this is called function as a service. And AWS Lambda is not the only provider out there. There are some more. And what you really can do is like, you can create a serverless infrastructure with Lambda and combination of other serverless products. So imagine like your application is single page app. Let's say written in AngularJS or React. So single page app. And for what you can do is you can take those static files like HTML, CSS, and JavaScript, upload it to S3. Actually, S3 bucket can serve static HTML files. So when a client comes to our website, he will load those static pages, and we will render the single page app. Now the single page app will communicate with some API. So for that, we can use another product from AWS, which is API Gateway. And that is providing JSON API on one hand, and on the other hand, it will execute Lambda function, give some messages, depends. So for example, this way we will execute the Lambda function, it will do this thing, return some result back to API Gateway that will render on the front end. Then if you have scenarios then where you need to launch other Lambda functions, you should not invoke it directly because you would pay for entire execution. But what you can do is you can queue a message into SNS queue or SQS queue, and those Lambda functions may be, so these are queue products from AWS, and those Lambda functions may be listening to these queues or messages, and they will get executed. So AWS has no problem with, let's say, communicating with Postgres or MySQL, but if you introduce like Postgres or MySQL to your infrastructure, it really is no longer serverless because everything else is serverless, but you need to run like a database that is running 24 hours. So you can use actually other type of databases like DynamoDB, which I would dare to call serverless database, because if you store 4 items in the Dynamo database, you are paying for 4 items in that table. If it's 40,000 items, you will pay for 40,000 items. Plus some other fees, but I'm not sure what those are. But you know, it's really, you just pay for what you need. For authentication authorization, you can again use another serverless product, which is, let's say, AWS Cognito, which will ensure that, you know, those requests will not reach the Lambda function unless they are authorized. But there is actually another cool feature that with, let's say, Cognito and DynamoDB, what you can do is like the single page app can actually directly access stuff in database. So you can read the items in a table, or you can update directly or delete items in a table. And again, the Cognito will ensure those requests are pre-signed. So it's not like there's no security level. There will be definitely ensured that those requests are pre-signed. Anyway, so now when you think about this, we can replace the entire architecture of microservices with Lambda functions and serverless technologies. So really, Lambda functions are just another way how to do microservices. Now, please don't rely on this graph completely. I just made it up, but you know, like theoretically, you can replace different parts and pieces. You know. So the question now is, how much code should be in the microservice this way? And in this case, you are really aiming for that first solution. So this much code. Just execute, do one thing, and spin down. So if tomorrow someone will think about, okay, this is cool, I don't have to pay for a server anymore, I will just launch my Ruby on Rails application with AWS Lambda. No, you cannot do that. You are really aiming for like spin, do one thing, die. Not now, so I don't lie, there is actually a way how you can run a web server in AWS Lambda. This actually feature I was not aware of about until a few days. But more you read about this, AWS introduced like launching web server inside the AWS Lambda purely so they can help developers migrate from microservices to AWS Lambda. So it's really more like a migration feature, because what will happen if you, let's say, your server needs to handle 50 requests to the single endpoint, sorry, to the same endpoint. It's not like you are running the same server in one Lambda. What AWS will actually do, it will spin 50 instances of that Lambda, and they will die independently of each other. So it will spin the server in every one of them, they will do everything, return some result, and spin down. So you can, let's say, run like Express.js applications like that in Lambda. So it's one-to-one mapping. And yeah, so spin, do its thing, die. If you really want to do some more business logic inside the AWS Lambda, what you can do is actually you can write like libraries related to the business logic. And then you will just configure AWS Lambda to, let's say, one AWS Lambda will execute one part of the library, another to execute another part. But the point is, like, think about it like same way as we were talking about the boundaries in a microservice. So every business logic library should be like a microservice bound context. Anyway, if this sounds really cool for you, yeah, go check it out. But I definitely recommending checking some orchestration tools like Serverless framework, because what you don't want to do is like upload a zip file for every AWS Lambda via web interface. That could be pretty time consuming. Bad news, there's no Ruby support. So usually function as a service providers are supporting Java, JavaScript, Python, but no Ruby. And I actually had the opportunity to speak with some Microsoft Azure evangelists. They told me, yeah, Ruby is coming, but they didn't give me any day. Same with AWS. I managed to join one ready discussion, like ask me anything ready discussion with AWS evangelists. I asked them, when is Ruby coming? They told me, yeah, it's coming, but we cannot give you any day. So it could be 1 month, 1 year, who knows? So that's why I created a petition. So if you're interested in this, and it sounds cool, and maybe you will have some benefit in your company, you can visit this webpage. Also, it will be in the link that I mentioned earlier. And it's like you can sign in with your GitHub account, this petition. I launched it like 3 days ago. I already have like 170 people signed it in. I don't think it will change anything. It's more about like pointing out to the function as a service providers, there is a huge potential with Ruby. And like where the market is, they will go to that technology. So now I was probably lying. Yes, you can actually launch Ruby in AWS Lambda, but it's kind of weird because you need to, let's say, launch JavaScript Lambda that will execute Ruby. So for example, there's a Ruby 2.2.2 binary called traveling Ruby, which is like a binary executable of this Ruby 2.2.2. So what you can do is like take this Ruby binary, place some gem files in it, some dependencies, wrap it in a zip file, and upload it to, let's say, JavaScript Lambda, and just tell the JavaScript code to execute this binary. So it's like JavaScript executing Ruby. Or same thing with Python, like Python will execute this Ruby. Or you can actually, because like there's a Java support, you can actually run a JRuby within the Lambda. Again, more you investigate into this topic, I will place some stuff in the link below, more you will see it's not ideal. So definitely some MRI support directly from function as a service providers would definitely help. Now, let's talk about the monoliths a little bit more. I didn't want to paint the picture like, like suddenly everyone is shifting to microservices or serverless. Monoliths are still valid. If your team have no scaling problems, if you are productive, if everything is fine, don't bother with like microservices or serverless. It's fine. Like monoliths are not going away. Rails is not going away. Ruby is not going away. Chill. The project is fine. But even so, if you discover that you have like some problems within your infrastructure, let's say with scale, what you can do is like introduce some like a hybrid solutions. So what you can do is you can extract various parts that are problematic into microservices. So for example, imagine the rest of the application will be monolith, and you will extract that product listing part to its own microservice. But nothing comes with a price. Now you are actually introducing some complexity into infrastructure. Then you need to think about, should I also refactor the authentication out, or should it be part of the same monolith? will that microservice will be just something that the monolith is consuming, or will I directly render it on the front-end side? So it's definitely not ideal, but if you have really good reason why your monolith needs to be scaling some part of application, there are some solutions. Also, let's say if some part of your application needs to be up all the time, let's say you have some SLAs of 9 nines of availability, but because of deployments crashing, sometimes you cannot meet that goal, maybe extract that part of application to serverless. Introduce some API gateway in front of it, or maybe invoke those lambda functions directly from your applications. There are many ways how to do this. And also, if you are interested in those team solutions that I was mentioning before with microservices, let's say in Ruby on Rails application, you can create bound context, or any monolith application, you can create like a bound context within your code base. So for example, in Ruby on Rails application, you will Rails generate engine for a product listing, Rails generate engine for basket, Rails generate engine for orders, for payment, etc. And try organizing your team around these natural boundaries of the monolith. Now, again, this is not ideal, because probably these Rails engines will share the database. There are some ways, let's say you can say, one microservice will use one data store, another will use another data store. But you can have also problems with dependencies. What if one team will introduce a gem that will break other part of the application? So it's not ideal, but it's definitely a good step. And even if this doesn't work out, the transition to microservices will be much easier. So if you really need to split after this to microservices, it will be much easier transition. So yes, I managed to make it in time. Does anyone have any questions? Okay, so that's all from my side. Thank you for listening.